Yeah, hello everyone. We are going to do today a problem with motions of particles inside capacitor. As you see here in the questions, here there is a capacitor which has a potential difference of V. The potential difference is the difference between the two potentials in this plate and this plate. This plate has 0 volt and the one up there here has 600 volt, and it is given by the questions here. So 600 volt is the potential of the upper plate, 0 volt the potential of the lower plate, and the PD between them is also 600 volt. Now, what happens here is that we have a particle. And that exactly the questions here. We are going to talk about the motions of a particle inside a homogeneous electric field. A particle, let me read the questions. A particle of mass 6.7 times 10 to minus 27 kilogram and a charge of 3.2 times 10 to minus 19 kilogram, which is 2 elementary charge, is placed near the top plate in an electric field similar to that shown in the figure above. The potential difference across the plates is 600 volt, and the separations of the plate is 12 millimeter. So this is D 12 millimeter. Now, calculate the force on the particle. Let's start. Force in electric field in general for all types of electric fields is always Q times E. Now, this E stands for electric field strength. Electric field strength. Electric field strength. Right? So, we have different fields, different electric field strengths. It can be E like K times Q over R squared divided by Q, which is K times Q over R squared, but that's for radial field. So the radial field is something else that we don't have. So this is not what we have. What we have now is a homogeneous field of a capacitor. Homogeneous field of a capacitor is just merely divine its electric field strength by force divided by Q, which is the opposite of the first formula, or it's just the voltage potential difference divided by the distance between the two plates, which makes the problem much easier than the one in the radial field. So this electric field strength is, once more, is for the homogeneous field, including the one in the capacitor. Homogeneous electrical field. Now, let's calculate E, because that's the only missing quantity that we do not know in order to calculate the force here. So I have E. E is PD, potential difference or voltage, divided by D. The potential difference is 600 volt divided by D. which is given as 12 millimeter. 12 times 10 to minus 3 meter. And that is 60 divided by 12 is 5. So I have 5 times 10 to 1 times 10 to the power of 3 volt per meter. Or our electric field strength is 5 times 10 to 4 volt per meter. And volt per meter can also be defined as Newton per Coulomb. And that is the answer for the question 1. And now, before you go to the second video discussing about the questions B, you may stop for a while, everyone, and try yourself do the problem B.